Hi everyone, I'm very happy to be your presenter. My name is Mike Hells and I'm Business Development Manager for Emerson, working with the Asco and Aventix brands. I cover EMEA for process hydrocarbon and will be your subject matter expert for this event. There is a lot to cover and we will be happy to give more in-depth explanations or training on any of the solutions that I will present. There will be a Q&A session at the end, so please use the chat box to ask any questions. And I'll remind you all that we have a one-to-one opportunities during the event and during the following days. Welcome to this safety and reliability event. A quick look at the agenda. So first we will be looking at safety in solenoid operated valves. This will give an overview of redundancy in solenoid operated valves, an overview of SIL and how it all fits together. Next we have a live demo showing a 1 out of 2 system. This will be using the Asco Actuated control system. Next we have a video showing Asco's first redundant control system, the high flow RCS. Next we have a video showing our latest offering, which is the advanced redundant control system. Next we have a couple of recent solutions that are using the advanced redundant control system, along with how we configure a new system to your specifications. Finally, we have an opportunity to ask questions in our Q&A session. Redundancy in solenoid operated valves. Safety, availability, or the best of both. 2 pilot valves can be used to operate, process or shut down valves. In this full redundancy mode, either safety or availability of the final element can be increased depending on the piping configuration. Safety is related to the integrity of the safety loop to perform its safety function, where availability is related to the production to maintain its function. 2 pilot valves connected in series, as shown, are operated in a 1 out of 2 voting by the logical solver. This increases the safety or PFD of the system. At the same time, however, it decreases the availability. In a 1 out of 2 configuration, 2 devices are used to perform one function. If either of these components or solenoid fails, then the system is tripped. With 2 devices, the likelihood of this happening increases. So this is in series, which is more prone to trips or what's known as spurious trips. Next, we have a 2 out of 2 system. In 2 out of 2 configuration, 2 pilot valves are connected in parallel. The safety valves can be pressurized if one is de-energized. De-energizing the second pilot valve will remove the actuator pressure and shut down the valve. This configuration is less sensitive for safe failures, reducing the number of nuisance or spurious trips, and increases the availability. However, a 2 out of 2 system is less safe compared with a 1 out of 2 system. So this system shown is in parallel. Emerson Asco have a specific 2 out of 2 configuration in which 2 pilot valves are connected in parallel. One outlet port is connected to the release port of the other, as shown. This provides the same safety but increases the reliability of the final element. Most redundant pilot valves installations do not provide indication of safe failure of one of the valves. Generally, online maintenance and testing of the solenoid valves is difficult without shutting down the whole process. Emerson Asco has re-engineered their solenoid valves to offer higher safety, easier installation and improved capability for testing and diagnostics. In addition, new solutions have been designed that cut engineering effort and greatly reduce the time for installation and testing, particularly when using multi-tool devices for redundant safety options. So this system provides greater availability and increased safety. Now we'll take a look at an overview of the functional safety for process sector. This is classified as IE 61511, SIS for designers, integrators and users. On the left we have a graphic of safety through layers of protection. Generally speaking, in operation we have a basic process control system, or BPCS, and preventative measures include something like operator intervention, which could be an emergency stop, or a safety instrumented system. If we take a look at a modern car, generally speaking, if you want the car to stop, then you apply the brake. Again, with modern cars, we have sensors that initiate the brake without us touching. So in effect, this is a safety instrumented system. When we're looking at components, we have IEC 61508 for manufacturers and suppliers of components, and this is a system known as safety integrity level that offers SIL level 1, 2, 3 or 4 capable. Anything SIL level 3 or above will need a third-party certification. Asco Emerson use Actuated for their third-party certification. This is an example of a SIL 3 capable device, which is the 327 used on our actuator control systems. And as you can see, it provides data such as the mean time before failure and fits, which are used in SIL calculations. So Asco has a number of solutions to offer for safety and reliability. Over the next few videos, we'll look at the actuator control system configured in a 1 out of 2. Then we have a video of the redundant control system, the high flow, configured 1 out of 2, 2 out of 2, and now 2 out of 3. Moving on to our final video that looks at the advanced redundant control system from Asco, configured 1 out of 2, 2 out of 2, or 2 out of 3, with more features.
So here we have an example of a typical valve actuated package. On the front is the controls. If I turn it around, you can see in this case a quarter turn actuator, and this particular model is a Scotch yoke type of actuator. We have a switch box to give us our electrical feedback, and this part represents the valve. Typical types of valve include a quarter turn, offset or triple offset valve, or a ball valve. The way this configuration is set up at the moment, the valves are in series. This is known as a 1 out of 2. A 1 out of 2 is more secure than a 1 out of 1 system, but is prone to what's known as spurious trips. I'll now initiate the valve. In this particular case, the valve in an actuated position is closed and the fail-safe position is open. Obviously that can be either way around depending upon the circuit. If it's an emergency shutdown valve, then the fail-safe position will be open or closed. What I will do now is I will now initiate a spurious trip. A spurious trip can be something where the control room has not initiated that change or not requested the valve to change state, but something has happened to initiate that change. A common fault in solenoid valves could be a burnt out coil. So I'm now going to remove the power from one of these valves that's in series with a complete circuit. I've now removed the power off this coil, which initiates a burnt coil situation, and the valve moved to its safe state. I'll reinitiate that coil, and what I will now do is remove the power off this coil, again imitating the spurious trip, and the valve moves to a safe position. Turn the coil back on, and what I'll now represent is an emergency shutdown or a signal from the main control room to change the state of the valve, and the valve moves position. So this again is a 1 out of 2 system, which is more secure than a 1 out of 1, which would just be one solenoid, but as we just explained, it can be prone to spurious trips. Many thanks.
Welcome to the overview of the Asco redundant control system. When customers are looking for a system that's dependable, on-demand shutdown solutions, one that maintains safety levels, protects workers and equipment, and is very timely and easy to maintain, the Asco redundant control system offers safety, reliability, while minimising downtime. The system is a complete packaged system which could be offered in a 2 out of 2 with diagnostics voting system, or a 2 out of 3 with diagnostics, which improves process reliability, maintaining safety, high availability, market-leading flow, and the best choice for actuation control of critical process valves and safety systems. It's pre-packaged. The enclosures available are in stainless steel or composite. It's IEC 61508 SIL Exceeder certified to SIL level 3. Its fault tolerance architecture has no single point of failure. There's no bypassing required, as the system has an integrated bypass system. There's no process interruption, which mitigates spurious or nuisance trips. With the help of automated online testing, inside the system we have a pressure switch, or the renowned TopWorks Go switch, which enables you to have feedback into your DCS system. If there are maintenance that needs to be required, we have a bypass module which can quickly bypass, and you are able to replace your coils or internal components. The Asco RCS system, saving time and expense, delivering safety and reliability, is the ideal solution. To learn more, please visit emerson.com/Asco. The Advanced Redundant Control System from Emerson. The system offers architecture which stays on and stays safe. The current design offers 2 out of 3 in increased safety and availability. Stay on even if one valve fails, stay on during maintenance, and stay safe. For increased availability, we also offer the system in a 2 out of 2 voting, which gives you increased availability. For increased safety, a 1 out of 2 system is also available in the Advanced RCS. Compared to conventional designs, a modular device is a lot safer and a lot more reliable. The Asco redundant control system offers high reliability and proven solenoid valve technology with our 327 renowned system. 2 out of 3 is also available with SIL 3. We have visual or digital status indication, online maintenance, so we're able to bypass the system, and hot swap individual solenoids while the system is still live. The advantages of a manifold are it eliminates piping and leakage points, minimises points of failure, increases reliability, and reduces the total cost of ownership. It's supplied as one complete module, is SIL certified, saves space, and is ready to install. Simplifies ordering with one part number of the complete system. A 1 out of 2 system gives you increased safety. In this example, we can see how the 1 out of 2 allows the system to be completely enabled. If one of the solenoids fails, then the system will close. In a 2 out of 2, this will give you increased availability. So in this system, both coils are energized. The system remains open. If one of the solenoid coils fails, the system still remains open. A 2 out of 3 is the best of both of these systems. It increases your safety and availability. As this demonstration will show, at least 2 out of the 3 systems need to fail before we have a total failure. This increases your safety and availability. A common bypass enables online maintenance. For example, if one of the solenoids needs to be maintained, then when the system is in bypass, the air pressure is removed, but the system still remains open. The system is now in bypass, which enables the customer to replace a solenoid or a coil, and then the system is put back onto line. There is no interruption of the circuit. Hot swap, individual isolation. A 2 out of 3 increases safety and availability. So again, in this example, we can see that we have isolated a single solenoid. The system still remains operational, and now the system is back online. Key benefits: we can offer a 1 out of 2, a 2 out of 2, or a 2 out of 3 functionality. As a common bypass or individual isolation, it's supplied as one SIL certified assembly, again reducing the total cost of ownership. What does it mean for you? Helping you meet your safety, performance and reliability objectives. Stay on, stay safe. To learn more, visit emerson.com/Asco. So as mentioned, we will now look at a couple of examples of where we've had success with the Asco Advanced Redundant Control System. So in this example, a customer wanted to reduce the nuisance or spurious trips to increase plant reliability for their critical loops. They wanted to reduce the downtime to minimise the extent possible, and together with local engineering and installation commissioning, we were able to support the project from start to finish. There you can see a number of the advanced actuator control systems prior to final installation. The next example is an advanced control system fitted inside a cabinet, and again this was something that the customer required and we were able to configure. and we were able to install these locally at our manufacturing plants in the local area, which in this case was Dubai, and well over 100 of these special cabinets were produced and installed for the customer. So now we're going to give a quick overview of how to configure an ARCS. We will now configure. So as you can see, we need a minimum number of 5 out of 5 attributes to create the configuration. So I've randomly selected 5 from each of the areas, which then has generated a model code. If we click Next, what the system will do now, it will go away and configure this and be able to produce us with a quotation, which we're able to send to our customer. So there we have an overview of what we've just configured. And then if the customer requires a 3D step file for him to enable him to put that into his CAD system, that's something we're able to achieve. So from this configuration, we're able to select several options. So there's a number of different formats that we can download the CAD file. We also have the option of a PDF 2D datasheet, all of which can be added to your quotation. If we look at the emerson.com website /Asco, from here we can look at these individual components by typing them into the search bar. So if we search for RCS, then we're presented with this page. And this is a similar format to all other pages within Emerson.com. So from here we can scroll to the bottom and download a brochure. And this brochure is an overview of all the products that we have in this particular range. So as you can see, we have the ACS and the RCS. If we look at documentation and drawings, we have their own catalogue, certifications, data sheets and bulletin. And here we can also download the information and maintenance sheets for all the different types of 2 out of 2 configuration, 2 out of 3 configuration. We also have the same with the Advanced Redundant Control System. So again, we download safety manuals or the instruction manuals or the general catalogue. This is the configuration table of the Advanced Redundant Control System. Schematics and logic tables and the different operators. Thank you very much for your time and attention there. We're just moving on to the Q&A session, so I'll just have a quick look to see if we've got any questions in there. We've got a question here as regards to what does SIL capable mean? I mean, that's a great question. SIL, as mentioned, is safety integrity level, But SIL generally refers to an assembly of components to create a function like an ESD valve. So the SIL level is calculated using all the internal components data. Generally speaking, most requirements for an assembly are a SIL level 1 or a SIL level 2. SIL level 3 capable means that this product is capable of being used to create an assembly that will be SIL 3 or above. So a SIL level is reduced by the number of components. So a SIL level 2 part cannot be used to create a SIL level 3 assembly. So it's to do with the calculations. But as mentioned, generally speaking, SIL levels required in general service are 1 or 2, unless it's a sort of really severe service or something like a nuclear installation. That they tend to be a little bit more advanced. So again, what solution should I offer? Okay, so that's a good question again, but there are a few factors that dictate, for example, what flow is required. So if you look at the RCS, the standard RCS has a higher flow than the ARCS in certain applications. And when we first looked at the live demonstration, I showed an ACS, which is an actuated control system. So that can be tailor-made to your own requirements. So we can put additional features on there. We can put lots of, valves and just basically make the circuit to anything you need. Whereas the ACS and the ARCS are designed in a particular way. So they're designed to satisfy your requirements. There's one or two more questions, but I suppose that we may be running a little short on time. So what I'll do is, the remaining questions, what I'll do is I'll come back to you by email. So that's probably the best thing to do, give a bit more in-depth explanations. If you do want to have a one-to-one, as I mentioned, there's a number of Meet the Expert schedules available. So I'll be very happy to speak to you either today or through the rest of the event. And I think it's open for a few days after. So once again, thank you all very much for your time and enjoy the rest of the event. Thank you.